So now is the type of steel. Steel can be derived from two raw materials, okay, which are the liquid pig iron and also scrap. So pig iron is raw iron, which is the immediate product of smelting iron ore with coke and limestone in a blast furnace. Pig iron has a very high carbon content, typically 3.5%, which makes it very brittle and not used directly as a material except for limited applications. Okay, so that is why we have to combine, okay, this pig iron, okay, with other types of iron in order to get the structural steel. So the iron making blast furnace produces liquid pig iron from the iron or limestone, coke and also air. The scrap used for the new steel making arises in the steelwork itself, which is readily characterized and usually recycled completely. Okay, so steel for structural use in hot rolled application may be classified into three categories, okay, which are the carbon steel, high strength low alloy steel, okay, and also the alloy steel. Okay, so you can see here, so these are the types of steel, okay, that is used to produce the structural steel. Okay, so as for the carbon steel, it contains iron, okay, 1.7% carbon, 1.65 manganese, okay, 0.6 silicon, and also 0.6 copper. Okay, so you can see that as for the carbon steel, okay, we have different percentages of carbons. Okay, we have low carbon, medium carbon, mild carbon, and also high carbon. As for high strength low alloy steel, okay, it is a carbon steel, okay, with addition of alloy element. Okay, whereas this alloy is to improve some mechanical properties and better resistance to atmosphere corrosion. Okay, so for the alloy steel, okay, it is a carbon steel undergone heat treatment. Okay, consists of quenching, rapid cooling with water or oil from temperature of 1650 degrees Fahrenheit, okay, to 3000 Fahrenheit. Okay, so this is a typo error, right? So it is to 3000. Okay, then reheating to 1150 Fahrenheit. Okay, and allows cooling. Okay, tempering reduces the strength and hardness. However, it will improve the toughness and also the ductility. Right, so that is why in the steel, okay, we are going to add up, okay, this alloy in order to get the ductile property. Okay, so for the manufacturing process, okay, of steel, okay, we will start with the primary steel making. So it refers to the refining processes used to produce liquid steel, okay, with the aim to produce a melt of the required composition. Okay, so the typical ranges required for structural steels are with the range of 0.5% to 0.25% of carbon, okay, manganese of 0.5 to 1.5%, and also sulfur and phosphorus of less than 0.05%. Okay, so the types of refining process, okay, that we can use to make steel, okay, is the Bessemer or Thomas process, the open hearth, okay, or Siemens process, the basic oxygen process, and also electric arc steel making. Okay, then we have the secondary steel making. Okay, the liquid steel process is not finished when it is tapped from the furnace. It must undergo further treatment, which is necessary to deoxidize the metal. It is done by adding manganese and silicon, which react with the dissolved oxygen to form insoluble particles of oxide. It may be necessary to adjust the carbon and manganese contents to give the grade of steel required, because with carbon it will improve the strength and manganese gives low temperature toughness. Okay, then the last one is the mechanical forming process, okay, which is used to convert, okay, the ingot or continuously cast materials into the shapes and sizes required. Okay, so it can be done either by hot rolling or cold rolling. Right, so this is the mechanical forming, okay, whereas we wanted to shape the material. Okay, so for hot rolling, okay, all constructional steel, okay, or structural steel are hot rolled. So these steel are heated to a temperature of 1000 to 1300 degrees Celsius to make them soft enough to deform and shape. Okay, and then we also have cold rolling. So cold rolling cannot be used to the same degree as hot rolling, okay, for shaping purposes because of the increased strength of the cold workpiece. Okay, so the modest reduction can be achieved by rolling to give better size tolerances and surface qualities. Okay, so this is for cold rolling. It is mainly for lightweight sections only. However, for structural usage, okay, whereas we are using beams and also columns, okay, that is of a large sizes, okay, so we are going to use hot rolling instead. Okay, right. So you can also look into the steel making process, okay, based on this YouTube channel. Okay, so I've already shared, okay, this video, okay, in your class notebook, right? So you can also view it there. Okay, alright. So next is the steel product. Okay, so these are the products of steel. Okay, so we have the hot roll product, okay, and also the cold rolling product. Okay, so for the hot roll product, okay, so you can see that the steel will be heated at the temperature of 1200 degrees Celsius to 1300 to make them soft enough to deform sheet. Right, so the examples of roll or form section, okay, are the universal beam, okay, channel, hollow section, universal column, angle, and also a T section. Right, so you can see here these are examples. Okay, so we have a circular hollow section. Okay, and also we have hot roll H section. Okay, here we have rectangular hollow section. Right, so these are the roll and form section. Right, so we can see that the section is produced as one. Okay, then okay, we also have the compound section. Okay, whereas we have a combination of separate roll section. Okay, for example, we have universal beam covered with cover plates, okay, or two angle welded together, or two channels welded together. Right, so as you can see here, this is one example. Okay, whereas we have a steel beam, okay, and it is connected to a welded plate. Right, so this plate, the function of this plate is actually for the purpose of connection. Okay, whereas we can attach the plate, okay, to another beam, okay, or another column, okay, and we can bolt the beam together, okay, with that structure. Okay, so therefore we are going to have the connection. Right, so if we have this kind of structure, okay, so therefore we are considering this as a compound section. Okay, then another one, okay, is a build-up section, okay, whereas we have welding plates together to form I, H, or box members. Okay, it is used to carry heavy loads and long span. Right, so we can see here that we have examples of welded box section. Okay, so we have plates, okay, then we weld it together, okay, in order to get the upper section. Okay, right, so instead of having the section roll or form as the structure itself, okay, but it is actually connected by the welding process. Right, so we have examples of welded box section, okay, welded H section, okay, whereas you can see that these shaded areas are the welded connections, okay, and also we have welded cover plate, okay, on a hot roll H section. Right, so we also have plates here, okay, and it is welded together to our section. Okay, right. So steel, okay, can also be used as a reinforcement in concrete. Okay, so the two types of bars that is used in reinforced concrete, okay, are hot roll mild steel, okay, with the yield strength of 250, and also hot roll high yield steel, okay, with the yield strength of 460 Newton per millimeter square. Right, so we also have a mild steel in the form of smooth round bars, okay, which is used for links. And also we have high yield bar, okay, which are produced in deformed bars. Okay, and then we also have other steel products, okay, that includes the prestressing steel, stainless steel, and also weathering steel. Right. Okay, so as for this reinforcement in concrete, so previously we have already learned on the concrete material. Right, so for this reinforcement in concrete, it is the concrete that is embedded in for this reinforcement. Okay, so it is the steel that is embedded inside the concrete. Okay, so for the prestressing steel, okay, or also known as tendons, are produced in the form of wire and strand. So steel for prestressing material may be made by any process except the air and mixed air or oxygen blown process. So prestressing are used in construction of bridges, buildings, stadiums, and others. There are three types of prestressing, okay, which are wires, strands, and also bars. Right. So usually, as for this prestressing wires, usually the strength is much higher in comparison to the reinforcing steel. Okay, then next one is for the weathering steel. Okay, it is a type of steel that develops a protective oxide coat on its surface upon exposure to elements, so that painting is not required for protection against most atmospheric corrosion. So it is suitable for use on bridges, okay, buildings, and also for decorative effect. Right? Okay, so this is weathering steel, okay, which can actually sustain the weather. Okay, right, then we have another one is a stainless steel. So stainless steel is defined as an iron carbon alloy, okay, with a minimum of 10.5% chromium content. The name originates from the fact that stainless steel does not stain, corrode, or rust as easily as ordinary steel. Right, so when we talk about stainless steel, it is a type of steel that will not corrode. Right, okay, so for example, if we are using the our kitchen tools, okay, so it is actually made of stainless steel, right? So it will not corrode. So this material is also called as corrosion resistant steel, okay, when it is not detailed exactly to its alloy type and grade, particularly in the aviation industry. So as such, there are now different and easily accessible grades and surface finishes for stainless steel to suit the environment to which the material will be subjected to its lifetime. Right, so however, usually as for this stainless steel, usually the material is quite thin, okay, and the material is quite soft, right? Okay, so usually we are not using this, okay, for the structural purposes. Okay, so for the connection, okay, we can also use steel, okay, for connections. Okay, so we have three principal system for connecting members, okay, using steel, okay, which are bolting, riveting, and also welding. So these connections need to join members together in trusses, plates together to form built-up members, okay, beam to beam, okay, beam to trusses, okay, and also beam to column in structural frame, and also column to foundations, right? So when we talk about connections, okay, we are going to connect between members. Okay, so this is one example, okay, whereas we have the bolt and also the base plate. So this connection is using the steel material. Okay, so for the bolting process, okay, so ordinary bolt in clearance holes, okay, consists of black hexagon head bolt, okay, nut and washer, okay, and force is taken by share of bolt body. Okay, so high strength friction grip bolt, okay, it is made from a high strength steel, okay, clamping force will transmit the force to the connected member by friction, and the surface in contact must be free from mild scale rust, paint, and grease, which would prevent solid contact between surface and the lower slip factors. Right. So we can see here. Okay, we have the bolts and also we have the plate. Okay, then we also have rivet. Okay, there are several common method of techniques for performing rivet operations. Okay, there are standard hand riveting with a bucking bar or blind rivet. Okay, so three basic alternative methods of riveting are cold riveting, okay, hot riveting, or automated riveting. So each method is used to achieve different characteristics. In the standard riveting process and in cold or hot riveting, a bucking bar is used at the bottom end of the rivet to cause it to form a head when the rivet is driven through the hole. So bucking bars are of different weight depending on the size of rivet being used, right? So this is the cold riveting process, okay, where the rivet is kept in a refrigerator until they are ready to use. Okay, so rivet is driven when it is still cold. Okay, and rivet will cure at room temperature and becomes hardened, right? Okay, so we can see here, okay, that we are going to rivet. Okay, so we are going to drive a hole here. Okay, then we are going to put the rivet inside. Okay, and it is driven in while it is still cold. Okay, then it will cure or it will harden, okay, at room temperature. Okay, and it is necessary for rivets to produce from certain aluminium alloys, right? So we need to have a certain material, okay, in order to have a rivet that is of a sufficient strength. Okay, then next one is the hot riveting process. Okay, it is done for the same reason. Okay, whereas we are going to connect usually two plates together. So rivet will be at room temperature before it is used. Okay, because this is considered as the hot riveting process. So when the rivet is needed, it will be heated then it is driven while it is still hot. Alright, so you can see here that this rivet or this material, okay, is driven into the hole, okay, while it is still hot. Then when it cools again, it will return to its hardened shape, right, or its hardened state, right. So we can see here that it has locked the two structures together, right. So this is where, okay, we are applying the riveting process, right. So we have the cold riveting process and also the hot riveting process. Okay, so the next one is the automated riveting process. Okay, so it is cheaper, but due to lengthy setup time, okay, they are usually limited to only one rivet type. Okay, so automated riveting, okay, can include the hot and cold riveting method together. Okay, so this is an example of a rivet machine. Okay, so usually this rivet um, technique, okay, which is used for the connection, okay, it is used for small connections, okay, so small materials connection, okay, where it can be connected with this rivet, and usually these rivet connections are considered as permanent connections. Okay, then the next one is welding. Okay, so it is a process of jointing metal parts by fusing them and filling them with molten metal from electrode. And it is extensively used to join parts and members, attach cleats, stiffeners, and plates, and to fabricate complete elements such as plate girders. Okay, so it produces neat, strong, and more efficient joints, okay, that are possible for bolting. Okay, and the two types of welding joint, okay, that we can see here are butt weld, okay, and also fillet welding. Okay, so the size of fillet is specified by the leg length, okay, and also the strength of weld can be calculated on throat thickness. Okay, so you can see here we have the butt weld, okay, which is usually whereas we can see that we have the welding that has the welding material, okay, on the surface. Okay, however, for fillet weld, okay, it is inside, okay, and usually it has like the shape of a curve. Okay, so these are examples of butt welds. Okay, so these are the examples. So we have a few types. Okay, and also we have fillet welds. Okay, whereas you can see here, okay, that we have the flat position, horizontal position, okay, vertical position, and also overhead positions. Okay, so these are for the fillet weld.